Hello guys, Winston here. Since I'm in the middle of a fairly lengthy project, this week's video is going to be a bit simpler than usual. I want to share a pair of basic projects I did this weekend that someone who's just run Hello World might find useful in order to build up to more advanced projects later. The first is an engraved tile or drink coaster that involves a tool change, and the second is a conversion of a JPEG to a vector graphic in Inkscape which can then be milled on your CNC. They may not be the most exciting projects, but I think they touch on some reasonably practical techniques that everyone should know. So, without further ado, the engraved tile, which I'll from here on refer to as a mini drink coaster project. To start off, you'll want to find or create an SVG to carve. It's not hard at all to make one in Inkscape, but I think it's even easier to find a design that you like online that's already in a vector format, especially if you're as lazy as I am. Once you have an SVG file saved to a convenient location, open up MakerCam and import your file. With the entire design selected, you can scale and translate it however you like. It's best to keep everything near the origin, although there's no need to get the positioning perfect at this point. Next, you'll want to add in the outline of your coaster to cut out. Although a circle would be the logical shape for this, I opted for a rounded rectangle to make the most of my material. Center your design inside the coaster and align it with the origin for convenience. For this project, I'll be engraving my design with a 45-degree V-bit and cutting it out with a 1/16 inch flat end mill. Highlight your design and assign a follow path operation to it from the cam menu. Since I'm using a V-bit for this part, the tool diameter you enter doesn't really matter except for purposes of visualization. I picked a target depth shallow enough that I could complete the engraving in one pass, and a relatively low safety height to minimize tool travel time since the cutter will inevitably retract several times during the program. Because the frontal cross-section of a V-bit is quite low, we can go with a pretty standard cutting speed of around 10 inches per minute, even though the cutter tapers to a very narrow point. Next, assign a profile operation to the coaster outline. We'll be using a flat end mill here, so pick safe values for whatever size cutter you use. Calculate everything out and then throw tabs onto your profile operation. When you export your G-code, be sure to save each operation separately. This way we can swap out end mills in between them. I'll be carving out my coasters on some red oak donated by a friend salvaged from old furniture. It'll hold up a little better than the pine I've used in the past, and it'll look better than plywood. For the first program, you don't need to do anything special, just position your spindle at a good starting point, start up Universal G-code Sender, plug in motor power, and hit send. Once the program completes, switch off your spindle, but don't power down the stepper motors. You need the system to keep track of its own position unless you have homing switches installed. Jog your spindle up so you have room to change out the cutter, and then manually return your CNC to 00 in the XY plane. You should not use the return to 0 function here because the Z position of your end mill won't be the same. Jog the Z-axis slowly until you're level with the surface of your stock material. Now you can load up your second program and cut out your tile. Finish with a hard clear coat and your pieces will be ready to go. A variation of this project would be to engrave your own images even if they're not in a vector graphic format. To do that, find something you want to carve and import it into Inkscape. With it selected, go to the Path dropdown and select Trace Bitmap. Now you may need to fiddle around with the settings here so that your image is properly isolated, but once your desired image registers in the preview window, that means you're good to go. If you're having trouble with this step, I've found that going into Photoshop or GIMP first and turning your image black and white can drastically speed up edge detection. You can also do this to manually isolate color channels or highlight features you want to cut to different depths. When you hit OK, it may look like nothing's happened, but actually Inkscape will have created a vectorized copy of your image. You can delete the original or just keep it there. It won't be carried over into MakerCam later. You can also throw text into your canvas, you just need to vectorize it before saving it as an SVG. Once you're in MakerCam, you may come to the unfortunate realization that you don't have a skinny enough end mill to carve out some of your designs. Here, for example, my letters were too fine to accommodate a 1/16 inch cutter. You can try scaling up your font size if this happens, but if you're pretty close to fitting, you can also just cheat it. When you're setting up your operations, just tell MakerCam that your cutter diameter is smaller than it actually is. The resulting shapes will be a little rounder and fatter than indicated, but unless you're a perfectionist, it won't really matter. The same goes for the pocketing operation of your image. If there are a lot of thin features that your end mill can't reach into, feel free to fudge it here as well. This program was run as one continuous step since I didn't want to do a tool change. After the program finished, I hit my little plaque with some spray lacquer and acrylic paint. I found that I had to water down the paint so it wouldn't retain brush strokes in the more open areas like the UAV pocket. And that's all I have for today. I hope some of you found this video useful. I want to thank you all very much for watching, and I'll see you in a few weeks with hopefully a plywood and plexiglass enclosure for containing dust generated by my Shapeoko.